Welcome everybody. My name is Bernhard Rümpfel. I'm an application engineer and trainer at Softing Automotive. Today I would like to talk about the need for automated ECU communication tests and our product, the test case editor. Let's assume a car manufacturer receives a new prototype of an electronic control unit from the supplier. At this point, it's not clear if the electronic control unit communicates according to the specification. This is why we need ECU communication tests. What are the main tasks of such tests? Well, first, the validation of positive and negative responses from the ECU. Then, the validation of timings, the so-called communication parameters. It's also important to check the ECU's behavior on invalid service IDs and parameters. And we would like to have a statistical overview for ECU software versions. ECU communication tests can be challenging. One of the reasons is the high number of electronic control units and ECU variants. A single ECU includes a big variety of diagnostic services and parameterizations. And above all, the same tests have to be repeated several times until the ECU communicates according to the specification. From that, we can conclude that these tests cannot be executed manually. There is a strong need for automation. The question is there an easy way to create automated ECU communication tests? Our solution from Softing side is the test case editor in OTX-Studio. From a previous video, we already know the script editor, where we program line by line. Another editor is the GUI editor, which allows us to create graphical user interfaces. Of course, it would be possible to create automated tests by traditional programming, but the easiest way is to use the test case editor, which provides predefined test steps based on OTX scripts. These test steps can be added by drag and drop. Let's have a closer look into these test steps. It is possible to send single services from the diagnostic database and check the response parameters. We can check the timings. It is even possible to send all symbolic services from a diagnostic database by just one drag and drop action. Then we can check invalid service IDs, and if none of the predefined test steps fits the test requirements, we can still define customize steps. Altogether, we get automated ECU tests based on OTX scripts. Let me highlight the benefits of the test case editor. First, the simple creation of automated ECU tests by drag and drop. The validation of positive, negative and invalid responses. For special test requirements, we can embed customized test steps. And we benefit from comprehensive responses and statistical analysis in XML and HTML. When using the test case editor, just 4 steps are necessary to create short ECU tests. First, the selection of the ECU variant. Then the selection of one of the test steps, followed by the configuration of expected response parameters. And finally, we run the OTX script and check the report file. Of course, there is much more happening in the background, which is done by Softing OTX-Studio for you. Now it's time to see the test case editor in action. Let's open the test case editor, which is a template of OTX-Studio. The test case editor can be found at the bottom of the window. Let's define a name for our OTX project. In the lower half of the window, we see that the Softing example project is used, which defines the diagnostic data based on the ODX standard. Here we see the graphical user interface of the test case editor. In the first step, we are going to select the ECU variant that we want to test. On the right-hand side, we see the predefined test steps based on OTX scripts. One of the major advantages of the test case editor is the possibility to test all symbolic services from the ODX database. If we want to test all read services from the diagnostic database, we can configure the service ID. Right next to the service ID, we see the expected response behavior, which is by default positive and valid. Now let's run test A. In the report, we can find statistics of the test case. This list shows in detail if the received response parameters were according to the expectations. The test case editor also provides the possibility to test a single parameter of a service. The corresponding service will be part of test B. In this example, we are going to use the read service for the boot software identification. Let's add the service parameter in a second step. Here, the focus is on the positive response parameter. In this field, a specific value can be defined for the response parameter. Let's run test B. The report shows that the receive parameter was according to the expectation. The test case editor provides additional report functions. For example, a statistical overview of all reports for a certain ECU variant. If we want to check a certain report in detail, we can open it. Another feature of the test case editor is to compare two reports. In this case, the last digit of the expected value is different. Now, let's summarize our findings. We talked about the challenges of ECU communication tests due to the high number of ECUs, ECU variants, and the big variety of diagnostic services. The same tests have to be repeated several times. The solution is to automate ECU communication tests based on OTX scripts, which can be created by drag and drop and which provide comprehensive reports and statistics. The realization of that is the test case editor in Softing OTX-Studio, which allows to validate the communication parameters, which allows to send all symbolic services from the diagnostic database, and which gives us statistics of reports. That was a short introduction into the concept of automated ECU communication tests and our product, the test case editor. If you are interested, check out our website, leave a comment below, or contact me directly. My name is Bernhard Rümpfel, and I'm looking forward to seeing you in my next video.